Hello and welcome to Everything E.M, your YouTube channel for Cambridge Environmental Management. In these content videos, we work through the syllabus step by step to cover everything you need to know without wasting valuable time. Let's do it. In the previous lesson, we looked at different energy resources, how they generate electricity, and their benefits and limitations. In this lesson, we're looking at how energy resources can be managed more carefully. Every country needs energy for homes, schools, hospitals, transport, and industry. But using energy can be expensive, and it can also cause environmental problems such as pollution and greenhouse gas emissions. Conservation and management of energy resources aim to reduce waste, improve efficiency, and make the energy supply more sustainable. You can find the latest syllabus document on the Cambridge International website. I've put the link in the description for you, but you can also pause the video here to see what we'll be covering today. The syllabus gives us several strategies for managing energy resources. These strategies either reduce energy demand, reduce energy waste, improve reliability, or help countries move towards cleaner energy resources. Reducing consumption means using less energy in the first place. This can include switching off lights, turning off appliances instead of leaving them on standby, using less heating or air conditioning, taking shorter showers, walking or cycling instead of driving, and reducing unnecessary travel. If people and businesses use less energy, less electricity needs to be generated and less fuel needs to be burned. This reduces energy bills, lowers the demand on finite resources, and can reduce pollution and greenhouse gas emissions. So this is a very important one. Then insulation reduces the amount of heat that can be lost from buildings in cold weather and can also reduce the heat gained in hot weather. Roof insulation, wall insulation, carpets, thick curtains, draft proofing, and double glazed windows can all reduce the need for heaters or air conditioners. If a building stays warmer in winter and cooler in summer, less energy is needed for the heating and the cooling, and this will have a wonderful impact on the energy demand. Energy-efficient devices, including vehicles and electrically propelled vehicles, is very important. LED light bulbs, for instance, will use less electricity than older bulbs. Energy-efficient fridges or washing machines or laptops or air conditioners, they all use less power. Hybrid and electrical vehicles reduce petrol and diesel use. The key point is that people can still use the equipment, but less energy is wasted. Exploiting existing energy resources mean making better use of the energy resources that are already available. This does not only mean using more fossil fuels, it can also mean using current energy resources more efficiently. So, for instance, using waste heat from factories, expanding existing renewable projects, or using waste materials to produce energy. Cogeneration systems can use waste heat from factories to generate extra electricity. And organic waste can be broken down by bacteria to make biogas. Some waste can also be burned to produce heat and electricity. This then improves the efficiency and reduces the pressure on fossil fuels. Education helps people to understand why energy needs to be used carefully and how they can reduce waste. Schools, media campaigns, government adverts, and community programs can teach people to switch off appliances, use energy efficient products, use public transport, and reduce unnecessary energy use. Education is important because many strategies depend on people actually changing their behavior. However, education alone is probably not going to be enough if people can't afford any energy efficient appliances or if alternatives are not available. Transport uses large amounts of energy, especially fossil fuels. Transport policies aim to reduce fuel use and pollution. Governments can improve the public transport, they can build safe cycling routes, encourage car share, introduce congestion charges, etc. Or they can limit where vehicles are allowed to be used. If fewer private vehicles are used or if vehicles use less fuel, the demand for petrol and diesel will decrease. This will then reduce air pollution and greenhouse gas emissions. Battery storage means that we are able to store the electricity when the supply is high and release it when the demand is high. This is especially useful for renewable energy sources such as solar and wind because they do not produce electricity all the time. Solar power depends on sunlight, wind power depends on wind speed, but the batteries can store the excess electricity generated during sunny or windy periods, and this can then be used at night or during calm weather or during peak demand. Developing new energy resources means investing in technologies that can reduce the dependence on fossil fuels. And we're specifically going to look at a couple on the next slide. Let's look at the two main sources of new energy: hydrogen fuel and heat pumps. So hydrogen fuel, we've got two kinds that we're focusing on, and that's blue hydrogen and green hydrogen. They're not actually blue or green, it's just to explain the process. So with blue hydrogen, it's hydrogen produced from natural gas, specifically methane. During blue hydrogen production, the hydrogen is separated from methane, which then means that we end up with carbon dioxide. But this is captured and stored so that we reduce carbon dioxide emissions into the atmosphere. Because it still relies on natural gas, which is a finite resource, this is not a renewable form of energy. However, green hydrogen is formed in a completely different way. This is produced using renewable energy, which then splits water into hydrogen and oxygen. And this process is called electrolysis. So electrolysis is when we use electricity to break the water molecules into their component elements, which are hydrogen and oxygen. So why is it green? It's called green hydrogen because the electricity that's being used comes from renewable resources such as solar or wind power, and the process of splitting the molecules does not release any carbon dioxide. Let's look at heat pumps. So we've got two kinds of heat pumps. We've got ground source and we've got air source. A ground source heat pump transfers heat from the ground into the building. So this is where the pipes are buried underground, and a fluid inside the pipes absorbs the heat from the ground. The heat is then transferred into indoors for heating. So important, they don't create heat. Heat pumps do not create heat like a heater does. All they're doing is they're moving heat from one place to another, which makes them very efficient. They do need electricity to run, and they can be expensive to install, and there usually needs to be enough outdoor space for the underground pipes. The other kind of heat pump is an air source heat pump. This is where heat from outside is transferred into the building. Even when the air feels cold, it can still contain some heat energy, and the heat pump extracts this heat and then transfers it indoors. Some air source heat pumps can also work in reverse to cool buildings in summer. Now, as I said before, they still need electricity, and they may be less effective in some conditions as well, especially where temperatures are just simply too low. Right, it's time for the pros and cons. That means we must look at both what each strategy can achieve and what problems it may still have. So if we look at the first one, which we think can have the biggest impact, reducing consumption, let's see. The benefits will be obviously that it lowers energy demand, reduces energy bills, reduce the amount of fuel burned, which means that there will be less pollution and less greenhouse gas emissions. Many actions are also simple and cheap, such as literally switching off lights or reducing unnecessary travel. But limitations are that it depends on people changing their behavior. Some people may forget, may not care, or may feel that reducing energy use is inconvenient. It can also be difficult to enforce or monitor, especially in homes and private businesses. Next one, with insulation. Well, this gives long-term energy savings because buildings need less heating in winter and less cooling in summer. And it reduces energy bills and can make buildings much more comfortable. Limitations, however, is it's always costly to install, especially in older buildings, and it can be difficult to adapt those established, rented or historic buildings because the walls, windows or roof spaces are hard to change. If we look at being more energy efficient, well, those devices definitely do reduce electricity use while still allowing people to have the same devices or equipment available. This lowers energy bills and reduces overall energy demand. Limitations: it can be expensive to replace older appliances, and then the disposing of these old appliances or vehicles can create waste management problems, especially if they contain electronic waste, batteries, or hazardous material. Exploiting of existing energy resources. The benefits are, if we're using existing resources more efficiently, we will reduce waste and make the energy system more reliable. For example, waste heat from factories can be used to generate extra electricity. Organic waste can be used to produce biogas. Limitations: existing resources are unlikely to meet all energy needs, especially if the demand is high or growing, as we see with our human population. Some existing resources still produce pollutants or release carbon dioxide, especially if they involve burning of fossil fuels or waste. Let's look at the remaining strategies and their benefits and limitations. Education. this increases awareness. If people understand energy conservation, they are more likely to switch off appliances, use efficient devices, etc., etc. Education can also be supported through incentives and grants, such as discounts for efficient appliances or subsidies for the installation of solar panels. Education still depends on behavior change, and people might not want to do, might know what to do, but might not want to do it. Legislation may be needed to make some changes happen, such as minimum energy efficiency standards for appliances or buildings, and information also needs to be shared in a way that is accessible to everyone, including different languages, income groups, ages, and education levels. Transport policies can reduce fuel demand because they encourage people to use fewer private vehicles or use more efficient vehicles. Better public transport, cycling routes, car sharing, and electrical vehicles can reduce petrol and diesel use. This lowers air pollution and greenhouse gas emissions. These policies, however, require significant effort and financial investment, and alternatives need to be available before people can realistically change their behavior. For example, people can't stop using private cars if public transport is unsafe, unreliable, or unavailable. Some policies may also be unpopular if people see them as inconvenient or expensive. And the last one is battery storage. Well, this makes energy supply more reliable by storing electricity when supply is high and releasing it when it is needed. This is especially helpful for renewable energy resources such as solar and wind, because their supply can be variable. Battery storage can then reduce the need for fossil fuel backup power stations, but batteries are made by using finite materials such as lithium, cobalt, and nickel. And mining these minerals can cause environmental and social impacts. Batteries can be expensive, they require maintenance, and eventually they need to be replaced or recycled. And there are these days large battery storage sites, but they can cause visual pollution. Right, it's time to finish this section by checking the key definitions. Let's go through the first one, which is electrolysis. This is the use of electricity to break down molecules into their component elements. Okay, in this section, we're specifically looking at electrolysis because it's used to split water into hydrogen and oxygen to produce green hydrogen. Blue hydrogen is then produced from natural gas. Green hydrogen is produced from the splitting of water molecules. Let's see, what else do we need? We need to talk about the air source heat pumps. This is a system that transfers heat from the air for heating, and the ground source heat pump is a system that transfers heat from the ground for heating. You will find the full list of terms and definitions on my website. Well done, you have now completed topic 1.5, Conservation and Management of Energy Resources. You can find study notes, the worksheet, and flashcards on my website, link below in the description. If you have any questions, please ask me below, and if not, I'll see you in the next lesson.